So now, we're just going to do a short demonstration of this module right here. So it's a voltage boost converter. I have the power supply set to 5 volts. That's not enough voltage to light this LED module right there. We need, closer to 12 volts. So I think like 9 volts would be enough. But in any case, we are going to plug the alligator clips from the power supply onto the voltage boost converter right there. And you need about 1.5 amps of current, otherwise it might not turn on completely. But there you can see we got right now this module set to 19 volts, so 5 volts coming in and it's doing 9 volts coming out. It's converting some of that higher current there to extra voltage. Now if we want to adjust that setting, we have a trim pot right here. If I turn it counterclockwise, then it raises the voltage. Turn it the other way, the voltage goes down. So now, I made the beginning of the video short to make a short out of it, but also a lot of people just like you to get to the point and make a short. For those of you that want a longer version, here we go. So this is an LED module right there. This circuitry right there, that's a diode bridge right there. You can take alternating current and power this. The diodes make it direct current as far as the rest of the circuitry is concerned. And then the rest of the circuitry, I think, ends up getting 5 volts to the LEDs. But you need a higher voltage coming in. This is a buck converter. So we can show that right now. Power supply is set to 5 volts. And I'm going to carefully attach to avoid a short circuit. You would not do this with a battery, but we got short circuit protection here. If it's way too easy to get to 1.5 amps of current, this will shut off right there. So we don't have to worry about a short circuit if I accidentally connect that wrong. But there we go. So the supply voltage is not high enough. We need, looks like at least 8 to get a little bit of current going through. It's not even that lit. Now 9 volts, it's actually lit fairly bright right there. And we can keep going up. We can actually put about 30 volts across here, as you can see right there. It needs less current because we got more voltage. It's converting power right there. So we got a built-in buck converter when it comes to that LED. Now I'm going to lower the voltage back to get to the right spot. Back to 5 volts for the rest of this demonstration because that's kind of where I began my journey today. Actually, I had lower current, but we'll get to that later. So now, a lot of voltage boost converters, they're just called boost converters, but I'm saying voltage to remind you, it's converting a voltage. A lot of them, they don't even work at 5 volts, but I grabbed this module out of my storage, and I don't even see a part number on it or anything. So I didn't know for sure if it was a boost converter or a buck converter. And when it comes to voltage, when it comes to boost converters, you don't want a higher voltage coming in than what you're outputting. So if you're testing to see which one it is, from looking at it, you can tell it's probably one or the other. Then what you simply do is you can lower the current to a safer amount. I did have it about 0.5 volts. And I accidentally, while I was filming this, the original scene, I accidentally wired these backwards, not in the one that I kept. This kept short-circuiting, and that didn't work, of course. Finally, I realized I put the alligator clips in the wrong spot. But in any case, we can put the alligator clips on there. And yeah, that's what I did. And it didn't say 20 volts, it said 15 volts at the output right there. I bumped the power supply, that's why we kind of saw that little signal there. This loses power briefly. So yeah, there you can see. That's the power that's needed to just power the module right there. It's lighting the LEDs and doing the rest of the circuitry right there. So we had in the demonstration 1.5 amps, and I'm going to lower it back to, well, in this video it was 1.5 amps, but 0.5 amps, and put the light in. So I'm not going to screw the light down, probably won't need to, but in any case, there you can see it's not working right now. It's probably making a good enough connection, but no, you can see that lower voltage there. You see a little flash and everything. And so yeah, that's why, turn the power off, turn the power on. We kind of need a boost of current. We don't need 1.5 amps, and I think I lifted this to 1, yeah, it's still not working. Let's go now 1.5. I think it will flash and then stay on right there. So yeah, we don't need more than 0.5 amps of current, but there's a brief period where we do, and for whatever reason. So that's why I got the power supply limited to 1.5 amps. But in case, that was the process that I did. And you really got to screw this down. This is in kind of loose, but it's making an okay enough connection right there. So we got that. So yeah, right there is the output voltage. And I can press the button right there. That's our input voltage, 5 volts. Looks like it's landing pretty spot on right there. I'm going to get that light out, and this doesn't get that hot. Of course, it's probably get hot if you sit around a while. So yeah, looks like it went up a tiny bit. Kind of looks like, depending on how well the alligator clips are clipped. But in any case, we got about 5 volts right there. That'll help you see this a little bit better, the display. So what I can do, I can actually adjust this a little bit. Again, I didn't read the instructions on this at all. I just pulled it out of storage where I store components. But in case, I gotta hold that down a bit. Now you can see 0, 0. So it was pretty much spot on, 5 volts. What I'm gonna do is press the button, and okay, looks like we got about 0.5 volts either up or down. So let's go 0.5 up. So if the display was wrong by a little bit, that's right, I gotta hold it down and then release it. Now you can see it's about 0.5 volts higher than what we got right there. And then hold it again until it flashes. I thought we lost connection there. And yeah, I'm surprised it's not. So let's try 1, 2, 3. Yeah, now it's not letting me adjust it. That's not a good sign. I didn't have that problem before. Maybe I'm not holding it long enough. Let's keep holding it down. There we go. So yeah, we can go to -5 now. It'll be about probably a 4.5 volts. There we go. Once I release it right there. So I'm not going to drag this out if this doesn't work right away. Let's try it. There we go. Good. Yeah, I don't know what that problem was before. So yeah, it starts with the positive up to 0.5, then the negative 0.5. Now we got it back to 0, and we're going to lock it in place. So I don't think there's any point to demonstrating it, but you can do that for the output voltage as well. So in any case, this has the voltage on there. We could measure the voltage, see how that accurate that is as well. But in case, we just saw how we can adjust it. And so we got the display, and I didn't have to read the instructions at all. It's been a long time since I used this, and I was just able to quickly figure out everything I needed to on my own to see what the component can do. So I'm guessing it said that you can put 5 amps through here or something. That's my guess. That's kind of common for them to say with these modules. But if there's no heat sink at all, then I usually limit it to 1 amp. And with this heat sink right there, I might do like 2 amps or whatever. But these aren't terribly expensive. So, you don't need to try to squeeze all the current out of them that you can. You can get bigger units where you pay a lot more money, where you can get a lot more current flowing through them safely. I don't think this would dissipate like 5 amps. I generally, unless the unit's really small, I generally limit to 1 amp. And then if it looks like it can dissipate more heat, about 2 amps. That's my safety margin. Of course, you do what you want to do, and if it doesn't work out well, you learn from that. So now, if this did not have the display, I'm going to show you what I would have done if I cared enough to look at what this unit does. So set the meter to measure voltage. It's really safe to measure voltage, but if there's numbers there, set it to a number higher than what you can expect to measure. With this particular multimeter, I only have to move the red probe if I'm going to measure high current. Voltage or anything else, I leave it there, so I don't have to worry about where those probes go. So now, again, let's connect this up. And again, when I connected it backwards before, I kept getting a short circuit. It would shut off. It would show that current. And I thought I might have fried it, but luckily I did not. So just something to keep in mind. So yeah, it's set to 20 volts. and we can look at what the actual output voltage is with the multimeter. So if, like I said, if this didn't have that display there, this is how I would have to look at whether it was a boost converter or not. And there we go. And I don't know why the power cut off. Probably because when I moved it, it affected how well the alligator clip was connected right there. So not the best setup, but we're just testing out. There we go. So yeah, it's about 20 volts right there. So we could again adjust it. We looked at adjusting it before, and now that's the input voltage does not determine that. So I might have a 10 volt power support, 10 volt power supply or something that I'm going to send to this, and I want it to output 20 volts. So if I raise this up to 10 volts, it still converts it. And if you have a load, it might kind of act funny. Well, you change it. But in any case, 10 volts, it still says 20 volts right there. And so I'm going to hopefully, keep this from sliding enough to lose connection. But in any case, there you can see, still 20 volts out because we got the 10 volts coming in. Now, if I have the light back on here, I'll grab the light. So we will see, it's another thing you can look at. This has taken a higher voltage, given a lower voltage to the LEDs. So the amount of power it needs stays constant. So we're giving it a steady volt. This is going to, keep giving it the same amount of current. But we got 10 volts from our power supply right there, which could actually light this by itself, as we saw earlier. But in any case, we're interested in the boost converter. So you can see before we had more than 0.4 amps of current when we had the 5 volts. It keeps going out because I kept losing my grip with the alligator clips. In any case, we'll go back to 5 volts. There you can see. Now we need close to twice the voltage. Not exact. There's some losses involved with the conversion, and then the unit needs some power to light the LEDs and so on. So you always got to take those into account as well. But in any case, I can't bring this up to 20 volts. I need to stay probably at least 5 volts to be safe below what we're outputting. So I would not do this if I have this set to 15 volts. We got 15 volts coming in right there. It went down a little bit more. So something else to be aware of with these. That's why I started off with 5 volts. Again, some of these units will not be able to power a load if they only got 5 volts coming in. Some of them are like 8 volts, maybe even 10. And like really high power ones might even need 12 volts. I don't know. You got to look at them when you're buying them. That's something to consider. Just be aware of that. But with this one, 5 volts did work. So if I took a portable power supply, and I do have alligator clips. I don't know. Yeah, I got one right here. So I have a portable power supply. I don't like that one as much. Right there. This outputs 5 volts. Pretty straightforward. We just gotta plug it in. And sorry, it's blurry. And now we come back here. It's going to be upside down, but yeah, it doesn't care that this is, oops, make sure you're getting the right one, in negative right there. You can, just accidentally attach one, but not both of them. No power go through. But yeah, there you can see it's upside down, but it's the 20 volts. We can add the LED and still light it with that power supply right there. Doesn't matter where the 5 volts comes from. So if you want to use one of these portable power supplies, though, you got to make sure you have a module that can change those voltages. So really long explanation, but some people like that, especially if they're completely new. So I'm okay with that. If you understood everything in the first minute, you should have just watched that and then moved on. So don't complain it was too long if you thought it was too long. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.